Today we're going to be working with the activity 2.6, but first I want to use some of them to get a review and a little better. Okay, so get ready please for the activity.
End of domain.
Yes. Okay, ready?
Yes.
Fine. In the activity, in the first part, we have a piecewise function. Okay, and the idea is that for every value of x that is in the list, tell me the type of discontinuity that you have in there. The type, not just that it's there, but you have a type also. Remember, from what I saw yesterday, it's going to be removable, jump, infinite, or another domain. Okay? So, for example, it says x equal to -5. What kind of discontinuity do you have there? Very good. And domain. Ah? Why? Who can answer to Paul?
Because it's a
Exactly. The graph starts there. There is nothing before that part of the graph. So it's another domain. X equal to -4? Infinite. Yeah, infinite. Because one of the sides goes to negative infinity, so we consider that infinite. Very good.
Profe, ¿hay exámenes de viernes?
What?
¿Hay exámenes de viernes?
Quiz? Yeah. Where's the last quiz? Because the partial exam is next Thursday.
Thursday, no Friday.
Thursday.
No, obviamente pues se recién.
No.
Pero no Thursday, ¿no para física?
No, but the partial is the partial is yeah.
So when we have another that
Vertical asymptote, yeah. Because one of the sides goes to negative things. Yeah. Before I continue, listen this. Yeah, next Friday there's a quiz about what? About this, continuity, and about tomorrow's topic, which is derivatives using the limit definition. Yeah. Yeah. And the partial exam is going to be on Thursday, including, well, the last topic will be derivatives. So, it will be that. And I was thinking that since next week there's no tutoring because of the rules of the coordination. This Saturday I'm going to give a special, let's say, well, tutoring as a review for the entire batch. So it's optional.
what day?
Saturday.
What time?
¿La pueden grabar o...?
At what time?
Okay.
Perhaps, let me think. Either 9 or 10.
Okay.
So they're going to get I hope.
No, que grabar pequeñas.
I don't know yet. I'll tell you later. Tomorrow. Okay, let's continue then. Let's continue.
Yes, pues.
Fine. X equal to -3. That one is what?
Jumpy.
No. Yes. Why?
Why?
Okay, why? Listen. No. My bad. I'm sorry. I was thinking about that one. No, -3 jump. Yeah. My bad. I'm sorry. It's jump. Sorry. X equal to -1 will be removable.
Why removable? X equals 2 is also removable.
Let me explain again. Okay, x equal to -3, yes, jump. I'm sorry again. Why? Because from one side of the graph goes to the 2, and from the other side goes to the -1, so it jumps from one to another one. So you're right, it's jump. But at -1, it's going to be removable, because in this situation, at -1, the graph continues all the way, but the problem is the gap, the single hole in that value. So that's why the -1 is removable, but the -3 is a jump. Okay?
Yes.
Good. X equal to 2?
Removable.
Removable, yeah. X equal to 4? Infinite, yeah. And 5? Yeah.
Mr. Latuno,
Yeah.
jump for el.
Which one? No. Again. Here on number 2, at number 2, the graph continues. The only problem with this one is the hole in there. It doesn't matter if you have a point in another value. As long as you have the graph and a single hole in there, it's called removable. The jump is this one.
When the graph continues, but at the same time you have in the other side.
Yes. Good. Okay, listen, in the second part, the same thing as we did yesterday. You have a piecewise function. The idea is to check if it's continuous or not at the state points and then graph. Okay? So, from those 5 examples, A, B, C, or D, or E, which one do you think is the most complicated? So we can do
A.
E, D, okay. Let's try D then. Find it. Letter D, it says f of x equal to x squared minus 1 over x minus 1 if x is different than 1. And 1 if x equal to 1. Okay? How many step points I have in this piecewise function? All the hard ones. But then which one's in the to you?
1.
Yo creo que es la última,
Right?
Hay que hacer la última mejor.
Let's finish this one. Let's finish this one by now. Yes, it is. Okay. You only have one step point. Why? Because it's a single value where the value changes, unlike, for example, the first one where there are 3. Okay, in this one it's a single value. So we're going to analysis just for the 1. X equal to 1. First, remember, limit what? X approaches 1 from the first left. Limit x approaches 1 from the right. 1. Use another piece of paper.
Si fueran muchos,
Yes.
In this case, you have to write all
Or what, right?
all that. We write a 0 and we write 1 another.
Or you can do everything another. Okay, listen, I know the space to do everything in here is a little, well, not that big. It's not a piece of paper. Piece of paper. Just bring it up. Fine then. Then it says limit x approaches 1 from the left. Which part do I choose? The first part or the second part?
The first part.
The first one. Why?
Because it's different than 1.
Because it says that it's different than 1. Okay, so that means that it includes before the 1 and after the 1. So I'm going to use x squared minus 1 over x minus 1, right? Then evaluate. If I evaluate, what do I have?
1 minus 1 over
X
1.
minus 1.
1 minus 1, 0, 1 minus 1, 0. Now, Here in this case, it's a 0 over 0. Huh? Yes. And I'll repeat again, so you don't forget that in the quiz. You said, you have 0 over 0. You factor. Don't forget that. Okay? So, we're going to factor. How do I factor that? Over? Can I simplify?
Yes. 1 plus 1 is 2.
Huh?
And then you left all the
So the answer is what? 2. Then, from the right, x squared minus 1 again over x minus 1. Again, it's going to be 0 over 0. And again, the answer is going to be 2.
So the limit is going to be 2.
So the limit of the function is equal to 2. What does that mean? What does that mean that it has 0 over 0 and then a value? If I were to graph that, what does that mean? What it represents? No, a gap. So a gap, it's an empty dot. It's an empty dot because you have a 0 over 0, so it's going to be an empty dot or a gap at 1, 2. What about the f of 1?
1.
Why?
Because it's 1 is.
Because you use this one. X equal to 1, so f of 1 is 1, irregular. So, what kind of discontinuity I have? What's my conclusion? Removable. Yeah. Okay.
The graph, ¿cómo sería?
We'll see that. You understand that? Did you get that? Yes. Good. Now, we're going to graph it. What will be the graph for that function? Any ideas?
No.
Yes.
Eso lo vamos a ver el sábado.
Okay. Listen. Listen, please. Okay. With this information, yes, I know that there will be a gap at 1,2, and we know that we have a full dot at 1,1. That information. But what will be the shape of the graph? In this case, for example, if you notice this function, if I want to graph it, after I simplify it, I have an x plus 1. That x plus 1 is my new function, is my new graph. So if I want to graph this one, and it can be simplified, the simplified form is the one that I'm going to use to graph, by also adding the gap and the full dot. So how can I graph x plus 1? Yeah. It's a line. With y-intercept at 1 and the slope is 1, so we 1 rise, 1 run, and then just graph. That's my graph, but I need to represent what I have here. So it says that you have what? You have a gap where? 1, 2. 1, 2. There's an empty dot, a gap. And this f1 equal to 1 tells you that you have a full dot at 1, 1. So that's my graph. So, removable. That's it.
Okay.
Yeah, the graph of this is this. And the limits tell us that if you go from the left, you approach 2. If you go from the right, you approach 2. But the 0% tells us it's going to be a gap. and this point here is given by the f of 1. So it's removable.
So you always grab the simplified graph?
If there's a way to simplify the function, then yes. If there's no way to simplify, then you need to use the other information. Horizontal asymptote, vertical asymptote, the behavior, everything else. Good. Questions? Yes. Just to check the behavior. That one, the one that I'm checking, the graph is going towards a certain value, which in this case is 2. And also to do the continuity. If they are different, so this continuity. All of them are equal, then it's continuity.
Profe, ¿por qué en FP dados
Because the lateral limits needed to,
Ah, ok.
the full limit.
Y si nos da diferentes que no existen.
Fine then. Okay, let's do another one. What do you prefer, A or E?
Es como la de ayer.
I'll do A, you do D. Can I erase? Good. Here.
No, no.
Okay, the first one. How many step ones I have?
3.
3. I have this one, the minus 1. I have the 0, and I have the 2. So I need to do analysis 3 times. 1 for each step 1. To see if it's going to be enough. Okay. What do I do then?
If you check the limits of -1.
Yeah. First, limit x approaches -1 from the left. The limit x approaches -1 from the right. The full limit. And the function. The same with 0. Limit x approaches 0 from the left, 0 from the right, full limit, f of 0, and the conclusion. And the same for 2. 2 from the left, 2 from the right, full limit, f of 2, and the conclusion. Okay? Before you start asking, you need to memorize all of this. In the exam, I'm going to give you, well, the procedure. You need to remember which function has to be in each part and then solve. Okay? Yeah?
¿Por qué x equals 0?
Because that's one of my step ones.
Ah,
All different values and domain, all of them are step ones. You can have 3, 4, 5, whatever. In this case, you have 3. Fine. X equal to -1. Limit x approaches -1 from the left. Which part do I need to choose? The first one, yes. So it's going to be x squared -1, and then evaluate, and the answer is 0. 0 is a value, so 0 is fine. Limit x approaches -1 from the right.
The first one?
There's no value.
There's no value. Why?
Because it ends -1, not included, and it begins at 0.
Exactly. If you notice here, this function ends at -1, but then the next one starts at 0. There's nothing between them. So, can I approach -1 from the right? No, I can't. There's a space on the graph that is not there. So, doesn't exist.
Oh,
No function doesn't exist. So the full limit of the function doesn't exist.
And that -1 is also.
F of -1 will be?
Doesn't exist.
Why not?
Because it doesn't include the -1.
Because it's not included. It's not included. Different reason than this, different reason. The reason why it doesn't exist is because it's not included. There is no bracket. Conclusion then. What kind of discontinuity I have? Removable, jump, infinite, end of domain. What do you think?
End of domain.
End of domain, yes, very good. Why?
because
Because
it
it starts from the.
from infinity to
From
-1.
infinity to -1.
Exactly. It ends at -1. And then you need to go all the way to 0 to start again. So, end of domain. Yeah.
¿Por qué no existía la inflación?
No. I'll explain. X equal to -1. Okay. Explanation here. If you have trouble observing which function corresponds to which one, I recommend something. You can do a little sketch to see what happens. By using what? A number line. Una recta. That line is going to represent all x's. And in that line, you're going to put your step points. You have the -1, you have the 0, and you have the 2. According to this, before the -1, what function I have? X squared -1. Between 0 and 2, I have the square root of x plus 1. And after the 2, I have 2x. This is just a little diagram, so you can observe that, for example, if I want to approach -1 from the left, you use the first equation, which is this one. If you want to approach -1 from the right, well, there's nothing. So that's why I don't use anything. It doesn't exist. Wait. For example, in the, well, tell me a question. What's your question?
Si fuera included el -1, ¿habría en la 2 o no? ¿O tampoco?
No.
Oh,
No. The included part comes for this.
sí, pero y la 2 no.
No. Because you only approach. So in this one, if it's included, you use it here, not in the limit. Okay. Is that clear? You can just try to understand. It's going to be in the domain if one of the lateral limits doesn't exist, like in this case. You can just use that to your advantage. Next one. 0 from the left. Which one I need to choose? Huh?
It doesn't exist.
It doesn't exist. Why not?
Because it doesn't include.
Check the diagram.
There is no approach.
For the 0, you cannot approach anything. There's nothing. 0 from the right.
1.
The square root of x plus 1. Evaluate, and you have 1.
It doesn't exist.
0 doesn't exist. F of 0, can I do it?
Yes.
Where do I check that?
In
Where
the
1 is
Square root of x.
In the square root of x, so the square root of 0 plus 1 equal to 1. Conclusion?
That's a dot.
No. Discontinuity, what kind of discontinuity? No, again, end of domain. X equal to 0. Why? Again, lateral limits, one of them gives doesn't exist, end of domain, automatically.
If only one of them gives you doesn't exist.
Yeah. At least one of them. And the last one, x equal to 2. Limit x approaches 2 from the left. Which part I choose?
The second.
The square root, square root of x plus 1, and the answer is going to be square root of what? Of 2 plus 1, approximately 2.41. Or you can just leave it like that, doesn't matter. If it's from the right, For
The
the
third.
third one, so 2x. So 2 times 2 equal to 4. Limit of the function doesn't exist. F of 2? It does.
4.
Why? Because we check in the second one where the 2 is included. Yeah. This ones.
¿Por qué no existe el límite?
Because they are different.
So it's a jump.
Jump.
Jump E.
Is continuity at x equal to 0. And that's it. Because if you were to visualize it, for example, if you go from the left, you go to a certain value. If from the right, you go to another value. It's a jump from there. Of course.
And in this case, the limit of x approaches to the right is applicable and approaching from the left is applicable.
From the
Because from the left is because the left is the same answer as f of 2.
yeah, you could say that because those two are equal, there will be a full dot here. But this one will be
Entonces ahí en la gráfica el 2 se va a acercar al 4 por la derecha y a la izquierda va a llegar al 2 con el.
yeah. Yeah. Now, for this to be removable, like the other example, could be actually a gap. That this will be equal to this, all three equal, but this is different than the function. For this, like the other example. Good.
Entonces, ¿cómo lo replicamos eso?
Okay. Good. Can I erase something?
Yes.
This part? Okay, how can I grab that? X squared minus 1, what kind of function is that? A linear, no. That parabola, yeah.
Parábola hacia arriba.
Yeah.
We want the
Okay. Help me with that, please. How can I grab that parabola?
You go down one unit and then grab another.
Yeah. It's a parabola, so minus 1 is the vertex. You can give values to it, so one will be here and here. And, well, we're going to graph. Little less. Okay. Now it says that it stops at where?
-1.
Minus 1. So, and that's going to be what? Empty or full? So here will be empty, and I need to erase this part. Very good. Now, x square root of x plus 1. How can I grab that? Horizontal parabola, but move one space outward. So normally, the horizontal parabola starts at 0, 0, 1, 1, 4, 2, right? So we need to move it up. So here, here, and here. So that's the parabola, square root of x plus 1. Well, it stops at 2. 2, so more or less here will be what? A full dot here. Are you following me?
Yes.
More or less? Okay. If you forget how to graph this, you can tabulate the values. But make sure that the shape of the graph is correct. Because if you, for example, if you put it this is a line, I'll put it wrong. Or this one is a line, then I'll put it wrong. And the last one, 2x. What kind of function is that? Linear function? Yeah. That starts at 0 normally. Slope is 2, 1, and then use the line. And you have a gap here. And that's it. If you observe this part here, there's nothing between them, that's why it's not domain, but here is the same value, so it's a jump. Okay? Questions? No? Fine. So, well, to the other ones, B, C, and E, everything. So, work with them. By the way, the last part of the activity, cancel it.
Okay.
The last part, number 3, A, B, and C, the last part, don't do it. There's no need to. What? 1 to 7, 0. The slope is 2.
No.
Rise, run. Rise, run. Do the run.
No.
Because of this. At -1, that's 5. So it's 19. Here and you, they're equal. So pull that one that you want from the line too. Here and parentheses. So it's that. It's hard to visualize it. But actually, every time the two lateral links exist, but okay, but if you cannot see it before the
Y si te da todo en todo un mismo número,
because there are no discontinuities.
no, si te dan todas iguales, es
Continuous, like the one I did yesterday. All of them are equal, there's no discontinuity. Yeah, but again, it's from the right or from the left? Then it's not, yeah, there's the right, and then there's the left. Different like this. El limbo francés, por eso jump. Ya me descargaron.
Cuando es X más 5, se dice que se recibe ya, ¿no? Más 2
Si no incluye el F de 0, o sea, sí, eso no existe. ¿Cuál es ese?
Si me da así la gráfica, pongo a los dos sentidos. Esta es positiva y va hacia arriba y 4 y 2 y esta es negativa. Pues no sé si sí, porque es una línea profe, es la E no necesita, pues todo error. No sé, todo me dio. Es una.
Profe, ¿qué pasa si no tiene las propiedades?
¿Cómo se grafican las de 1 sobre 1? Profe. Bueno, espero. Sí, esto tiene cortes el pelo, cortes el pelo. A pesar de para el full limit no necesitas una ecuación. Para el full limit para eso. A ver, ¿tú cuál dices? Okay. Y ahorita tienes que buscar primero los locales que te da 4 y el full limit lo único que hace es si son iguales es 4, si no son iguales el error es ya, es lo más fácil. Y el 2 es cuando está incluido 2 y el 3 es como una Yo lo único que hice fue tomar esto, lo fui a G5 y ya es un... Pues este es hasta el 7, hasta el 7.
Vale, no, oye, ¿cómo se llama?
Así.
Esta,
O sea, tienes que hacer una línea de acá, una línea de los lados, aunque no existan estos dos, estos son diferentes, solo son puntos huecos.
¿cómo graficaste la B?
Haces dos líneas, porque esa no tiene esto.
¿Esta cómo la sacaste?
Pues X más 5, el más 5 es de intersección, es la intersección entre clases intersecciones, y como es 1, es 1, 1, 1, 1, 1, pero ya se gasta menos 2, y borra lo demás.
Y luego el otro termina aquí.
Ajá,
Y se juntan las dos.
Sí, sí, pero esta, ¿cómo graficaste esta?
Por eso, hace cuenta que se viene a hacer aquí, ¿no? Lo demás lo borré. Y de aquí, pues es otra gráfica que, ¿cómo se llama? El slope es de 2. 2, 1, 2, 1, 2, 1, 2, 1. Y así se
Before we go, at least let's try to start number at the letter E, because I think that's a little to you. Okay, quickly. If it says limit x approaches 0 from the left for e, which one I choose?
First one.
1 over x. 0 from the right, ln of x, and the function. Okay, so how do I evaluate this? It will be 1 over 0 from the left. Remember, the denominator is 0, you put the direction. And 1 over 0 from the left is what? Minus infinity. ln of 0 from the right is not 0, is not doesn't exist. You have an answer. The answer is negative infinity. How do I know that? Give values to it. 0 from the right will be 0.1 or 0.01, 0.001. Already did it. One of the activities, the second one. So this one, the answer is what? Negative infinity. F of 0 doesn't exist. Conclusion, infinite discontinuity. If I graph it quickly, if I graph it, the graph for 1 over x is like this, right in 3 raised, and in 3 raised, and the ln of x, like this. That's the graph. Okay, so listen, in the quiz or in the exam or both, you're going to graph it. So you need to review how to graph these kind of functions, all of them.
Is it okay to graph and you use like that?